Today the topic of discussion is tree data structure, and what we are going to study under tree data structure is adding a node in BST. Prior to this, we understood what is BST and how to search an element in BST. Now we will add an element in BST. Fine. Okay, so let's start. Okay, so add a node in binary search tree. So there is a binary search tree. You can clearly see this is a binary search tree where every element which is left to root are less than root, every element which are left to 15 are less than 15, and every element which are right of 15 are greater than 15. Fine. Okay, so this is BST. Now your job is to add an element. So what you will do, how you will add an element? Suppose you need to add 35. What you will do, first you will compare 35 with 15 is greater, you will move to the right position, you come here. You compare 20 with 35, it's greater, you move to the right position, 35. Then you compare 30 with 35, it's greater, then you will what, this 35 will be the right child of what, 30. Fine. So this is how you get the element. This is how you add an element to binary search tree. So first you find the location of a parent, that is where that parent will be, because every time you need to know the parent, where my parent will be. Suppose I want to add 11, I'll compare this 11. 11 is smaller than 15, I'll compare, I will come left and I'll compare with this. It's 11 greater, yes, I'll come here. Is 11 less, yes, I'll compare it. Is 11, yes, I'll come to the left. So this 11 will come over here. Fine. So this is how algorithm will work on. Let's start with the algorithm. Okay, so before starting, let me tell you one thing very clearly. This is actually a node structure of any tree. Tree. What is a node structure of any tree? If I say 5, 2, and 7, this is a BST. Fine. So if I talk about node structure, what will be the node structure? Node structure will be something like that. This is 5. Fine. And this will have address of left child. Left child is what, 2. So left child, this 2, and this will have address of right child. Right child is what, 7. This will have 7. Suppose this node inform address is 200, this node address is 300. So what will come here, 200, and what will come here, 300. It's just like doubly linked list. Fine. Okay, what is left to do, nothing, then it will come null, then null, then null, and null. So it's a linked representation of a tree. It's a linked list representation of a tree. Fine. Okay. So this is what I want to try to tell you. I was trying to tell you. Let's see the structure. So similarly, if you can see the structure is having 3 parts. One is data and 2 are pointers. One contains the address of left child, one contains the address of right child. Fine. Okay. So let's start with adding a node. So adding a node, we start. Okay. So we move to the driver code first. Driver code. This is the driver code. Here we are calling a function called add node and passing a value 7. The moment I call this, the it will jump to the definition and argument 7 will be passed. Fine. Now we have 3 pointer. Pointer of type BST. One is pointer n, one is pointer t, and one is pointer f. Fine. Okay. What I'm doing with this, I'm making a structure of that BST, and the structure of BST is what, it contains 3 parts. One is info data part, one is left pointer, and one is right pointer. I just told you. The moment I do this, what will happen, a node will get created. Fine, a node will get created. Okay, suppose the address of this node is 100. Fine, this 100 will be passed to what, n, because n is holding what, address written by malloc. And what is malloc? Dynamic memory allocation function, which creates whatever size we pass. We have passed the size struct BST, it will create like that. Okay, now as this node is newly created node, there will be no left and there will be no right. So what we do, we are passing n left null value. Okay, definitely this node name is n, and what am I passing is that left of n is null, left of right of n is null. Fine, that is left is null, right is null, and in info part I am passing a data. What is data? 7. So 7 came here. Fine. Okay, and in info part I am passing a data. Fine. Okay, so there are 3 arrows, you can clearly see. So if I say what is n, n is 100. What is n left? Null. What is n info? 7. What is n right? N. Null. N means null. Fine. Okay, so let's start. Okay, t is equal to root. So t is equal to root. If I have just started creating a node, is there any root existing? No, because I am just starting. So what will be the value of root? Null. Obviously, because I've just started. My first node is 7. So the current value of root will be null. So what will be there in t? T will have null value. So t will have null value. Fine. Okay. If t root is equal to null, yes, currently root is null because there is no node. So if root is null, then root is n. So this node, new node become root. And this is what I told you. The moment you insert first node, that become a root. So this root is having a value n. What is value of n? 100. Now root is also having a value 100 because n is a pointer. I just told you n is a pointer. Root is also a pointer. They both will point the address, that is 100. Fine. Okay, and I'll return. I'll again come to second call. Okay. Now I'm again calling a function with value 9. The moment I call, the value 9 will pass over here. Fine. I again created a pointer. Fine. I again created a node. So I'm again creating a node. Let's see. I'm creating a node again. Fine. And the name of this node is n. So again, the new node is n. Okay, now this will automatically get removed because it's a local variable, and once you come out of the local variable, this their existence existence became negligible. Fine. Okay, so this new node is created. What I'm doing, n left is equal to null, so this left is null, this right is null, and this n info containing the data. What is data? 9. So now 9 is there. Fine. Now I have to see whether 9 takes position left of 7 or right of 7. Fine. Okay. Now t is equal to root. What is there in root now? What is there is in root is having 100 value. What is there in root? Root is having 100. Do not get confused. Root is not having 7. Root is having 100. Root info is having 7. If I ask you what is there in root, you say 100. If I ask you what is there in root info, you say 7 is there in root info. Fine. Okay, so if now t is equal to root, so t also point to the root. Fine. Okay, so t is also pointing to the 100. If root is equal to null, no, now root is not null because root is 100. Condition becomes false. So I'll not enter this. Okay, I'll come here and check. While t is not null, is t not null? Yes, t is not null because t is having value 100. Yes, condition true. Is t info? What is t info? 7 is not equal to data. Yes, t info is 7 and data is 9. It's not equal. Condition again true. Yes, I again put a variable or pointer f to t. What is there in t? 100. F is also pointing to the 100. Now there are three pointers which are pointing to a same node, f, t and root. All the three pointers are pointing to a node 100. Fine. Okay, is data? Yes, that is 9 less than t info. 9 is no, t is 9 is not less than t info. So I'll move to the else part. T becomes t right. What is there in t right? Null. So the new value of t is what? Null. So the new value of t is what? Null. Because of what? This t is having t right, and what was t right? Null. So t is having value null. Again, without coming out of loop, I checked again. Is t is not null? No, t is null. Now condition become false. The moment condition become false, I come out of the loop and check this. Is data, what is there in data? 9 is equal to t ka info. There is nothing in t info. T is having a null, so condition become false. Okay, I move to this situation. Is data less than f info? Data, what is data? 9. Data is 9 as we have passed this 9. Is data less than what is f info? F is pointing to this node, root node. F info is 7. F info is 7. Is 9 less than 7? No, condition false. So I move to the else. What am I doing is that f right, this f right, this value, f right is having n. What is there in n? Suppose this address is 200, so n is having 200. So what will come here? 200. So what happened? You can see clearly this node is pointing to this node. So what 9 has become? 9 has become the right child of 7. Fine. Okay, let me rub all these things. Let me rub this. Let me rub this. Okay, let me rub this also. Let me rub all these things. Okay. Okay, the moment I do all such stupidity, what will happen again? Now what will happen again? The moment I do all such stupidity, what will happen again is that I again come to this function call. Okay, this function call is calling add node 4. I'll come here and I'll pass call and pass data as argument as 4. I'll again create 3 pointers. Fine. I again create a node. I'm again creating a node. Fine. The node name of this node is n. With this, n left has null. Fine. This node name is n. And right is what? Null. And then info is what? Data. What is there in data? 4. So 4 will come here. Fine. Okay. T is equal to root. What is there in root? 100. So T will point to this position. Fine. Okay. If root is equal to null, no, root is not null. Root is 100. So this is false. I come to this situation. Is T not null? 100% T is not null. Condition true because T is 100. T is not null. Yes. T info. What is T info? 7. 7 is not equal to data. What is data? 4. And what is T info? Yes. Condition true. 7 is not equal to 4. Fine. So I move here. F is equal to 2. So now F is also pointing to T. So F, T and root are pointing to a same node called root. Fine. Okay. Is data you are trying to insert is 4 less than T info? What is T info? 7. 4 is less than 7. Yes. Condition true. I execute this statement. T is equal to T right. What is T right? What what is sorry? T is equal to T left because this condition becomes true. So T is equal to T left. What is there in T left? Null. So the moment I execute this statement, this one, what happens? T becomes null. So finally T again become null. Fine. Okay. I do not come outside and again check this situation. Is T not null? No, T is now null. Condition false. I come out of the loop. I check this. If data is what? 4 is equal to T ka info. T info, T is already null. What is there in T info? Nothing. Condition becomes false. Fine. Okay. What I came outside this and I check is data. Data is what? 4. Less than F info. What is F? F is pointing to this root node. F info is what? 7. Yes. 4 is less than 7. Condition true. What am I doing is that F left this value contains what? N. What is N? Suppose the address of this node is 300. So this will contain what? 300. Fine. And you can see the beauty. Now this root is the root left is containing address of node 4 or node having value 4. Fine. So you can clearly see 4 is at left of 7 and 9 is at right of 7. So this code is working perfectly fine. Now let me tell you one thing more which I have not told you. This code, you have always been confused that what am I doing in this code? So it's very clear to explain you the code again. Okay, let me have one more function call, and the function call is add node 9. What is 9? 9 is a node which is repeated. So where 9 will come? Suppose I'm starting in a natural manner. 9 will compare with 7. 9 is greater than 7. 9 will come here. 9 will compare with 9. Is 9 less than 9? No. Because 9 is not less than 9, 9 will not come to the left. Is 9 greater than 9? No, 9 is not greater than 9. So 9 will not come to the right also. So where 9 will go? 9 will be rejected. If some information are being repeated in what? BST, then that information gets what? That rejected, because you cannot put 9 to the left of 9 and you cannot put 9 to the right of 9. Fine. Okay, let's start. Okay, add node 9. Okay, fine. The moment I call 9 comes here, again 3 pointer created. Fine, I have created 3 pointers. Again one node is created. I'm creating a node. See, I'm creating a node. This node is n. Left contain null, right contain null, and info contain 9. Fine. Okay, is T, what am I doing? T is equal to root. So root is 100. T is also pointing to the 100. Fine. If root is equal to null, no, root is not null. Condition becomes false. Why root is not null? Because root is having 100. Okay. Why T is not null? Yes, T is not null because T is having 100. Fine. Is T info, what is T info? 7 is not equal to 9. Yes, 7 is not equal to 9. Condition true. I came here, F is equal to T. Now F and T and root, they all are pointing to the same node. Is data, what is data? 9 is less than T info. What is T info? 7. No, 9 is not less than. So what I execute else statement? T is equal to T right. What is T right? T right is now 200. The moment I do, T comes to the point node 200 because T is T right. T came over here. Fine. Okay. Now again I go up and check. Is T not null? Yes, T is not null because T is 200. Fine. Very good. And T info, what is T info? T info is now 9, is not equal to data. Data is also 9. Is 9 not equal to 9? False. This become false. The condition, the moment condition becomes false, what happens? What happens exactly? I come out of the loop. The moment I come out of the loop, I came here. Is data. Data is what? 9. is equal to t info. What is t info? 9. Yes, this condition becomes now true. Yes, true. So I inserted, I came inside and said what? Duplicate value and return. I did not do anything. I simply returned. So this was all about what? Adding a node in a binary search tree.